Hello, student, right? Thanks to attend the lecture on using the random mode teaching, right? We'll start on using the small chapter 3 probability, right? And you should receive the notes and exercise that is about probability, right? And the random mode teaching arrangement is student, please watch the teaching, okay, watch the record before you attend the tutorial, no matter in person or use the Zoom to attend the tutorial online, right? And we will use this mode in this semester, right? And if you have any problem on this, you're welcome again to raise question in the tutorial or send me email, right? Now, Chapter 3 is about the probability. I believe that some content you already heard them in your secondary school, right? But I will also introduce the symbol we commonly use in probability, the rules we use them, and the different situation and how do we apply the probability knowledge on solving the problem, right? Probability 中文係概率啦嚇，OK right, and it is start from using the set theory, OK set theory, right? In Chinese is called 集合啦嚇，集合定律啦。To on teaching the probability, right? And first is we define what is a set. Set is a list or collection of objects. The objects are in the set are called elements. Or members of the set. And if X is the element, we use this symbol to represent the element. That means belong to. The elements belong to the set. If we add a stroke, it means does not belong to or is not an element of the set. Another is if every element of a set B also belong to set A, we said that B is contained in A or B is a subset of A. 中文呢就叫做子集嚇 OK, the symbol is this. Now don't mix up with this symbol and this symbol. This is for the element belong to. This is for the set and the subset, right? Let's see one example. If A, there are 5 elements in A, 2, 4, 6, 8, 10, and B, it contains 2, 8, 10. So obviously, the element in B also in A. We said C is a subset of A. If another set is 1, 2, 4, but 1 is an odd number, right? And this is not in A, so we say C is not the subset of A. And to define the equality, we said if two sets they are equal, if the element in A is also the element also in B, and also the element in B, they are also in A, right? Okay, so this is the define the equality of the set， 即係話一個喺一個裏邊的都係喺另外一個裏邊咧，咁就叫做即係等價啦嚇。And the universal set in Chinese is 叫宇集合 is the set which contain all possible elements within a particular application under a consideration. A very simple example is if you throw a die, then we said the universal set is 1, 2, 3, 4, 5, 6. In other words, the universal set is the population. Okay, is the population. All possible elements are included in it. Okay. Another thing is sometimes if in a set there's an empty, this is something like an empty box. Although there is a box, but nothing is inside, we call that this is a empty set or null set. We use this Greek symbol phi to define it 呢個叫做虛集個集裏邊係冇嘢嘅冇嘢嘅 right okay now it's quite common to use this technique called Venn diagram to illustrate the relationship between the sets. Okay, it is a very useful and method to illustrate the relationship between sets, and also is quite easy to learn. Say, let's see one example. Now this is a typical Venn diagram. The rectangle represents the universal set. Okay, and we draw circles to represent different sets in the universal set. So from this diagram, okay, U is the biggest. Okay, U is the greatest, right? So A is a subset of U, B is a subset of U, C is also the subset of U, right? And from the diagram, we find that C is also in A, so C is a subset of A, right? Apart from this relationship, no set is a subset of the other, right? Okay. And on the other hand, we see C and B, there is no intersect, nothing in common. So they do not intersect each other. Now, and instead, sometimes we use this mutually exclusive to describe the two sets. There is nothing in common, right? And finally, the circle represent AB have some common area so that there is an overlap between A and also B. Okay. There are some operation on set. First is intersect. 中文咧就叫相交啦，交集。Okay, if the intersect of two sets denoted by these, okay, please remember this symbol. It's the set of elements which belongs to both A and B. A and B. Okay. If you use a Venn diagram, this graded area, it represents A intersect B. Okay, A intersect B. For example, if A is 1, 3, 5, 7, 9, B is 1, 2, 3, 4, 5, A intersect B, the elements are 1, 3, and also 5. Okay? Okay. But if A and B have nothing in common, we said that they are disjoint. Okay? Disjoint. Nothing in common. Okay. So A and B are disjoint if you try to find the intersect, but there is nothing. You find only an empty set. Okay. The second one is union. Union 咧就叫做聯集啦。The union of two sets A and B denoted by this one is the set of elements which belong to either A or B or both. If you use a Venn diagram, this greater area, it represents A union B. Okay, A union B. All right. For example, if A contains 2, 4, 6, 8, 10, B is 5, 10, 15, and also 20. So AUB, it contains all the elements from A or from B or from both. Are you clear? Okay. So example 2 is an example to show you if the universal set is a lowercase letter, and A is represent these, and B and C. After you do the operation, what are the elements. Okay, hope that student you spend time read example 2 in detail, so you understand the operation of union and also the intersect. Okay. Okay. Next is the complement. Complement, that means is not A. Okay, not A. Sometimes 中文叫做非雜。Okay, sometimes we are interested not only in the objects belong to a subset, but also in the objects not belong to the subset. It gives rise to the concept of complement. Different textbooks use different symbols. Some textbooks use AC represent a complement. Some A dash and then use A bar. Okay, so I usually use A bar. Okay, to illustrate the complement. So if the white circle is A, its complement is the element outside the circle. So if the universal set are the number from 0 to 9, and A is 1, 3, 5, 7, 9. So A's complement is 0, 2, 4, 6, and also 8. Okay, easy, right? So, and also you find that the A, okay, A union the not A equal to the universal set. Okay, get it? If A combined with the not A is the universal, that is this one. All right. Okay. Next, we go to another definition. Is called the sample space and event. Okay, sample space. In Chinese 叫做樣本空間嚇，樣本空間。What is sample space? Let's see one simple example. If you roll a die and observe the outcome, okay, observe the outcome. You should expect the outcome. They are one of it. 1, 2, 3, 4, 5, 6. Although you can't predict with certainty which of them will actually show up, but then this is called the random experiment. Okay, so 這個隨機實驗嚇。When a random experiment is performed, the set of all possible outcome is called the sample space for the experiment. We commonly use S to represent it. In other words, sample space correspond to the universal set in set theory. So that is the whole population. Okay, whole population means the universal set. The universal set, it implies means that is the sample space. So a very simple example is if you roll a die, the number shown on the top face is observed. Write down the sample space. 1 to 6 is the sample space, right? And the B, the event A, the number shown is odd. Okay, odd number. Third is the divisible by 3 or 6. Okay, 3 or 6. And D, now be careful, the event that the number shown is odd or divisible by 3. So we want to do the union of A and B. So we select all the elements from A, all the elements from B, put them in the same box. Okay, so it's 1, 3, 5, 6. 1, 3, 5, 6. And the intercept is the elements in common, so it is 3. All right, understand, student? So you understand what is the sample space? All right. Okay, next. Now then we go to the fundamental concept of probability. We learn probability in Form 3, right? Then probability is a numerical measure of chance of the occurrence of an event. Its definition is quite simple, right? This is the definition of probability. And n, this small n represents how many, that is the quantity, the number, okay, the number. A is an event, okay, as an event. So actually, probability is a ratio between the number of events of a particular event and is over the sample space. So the probability you get even number when you roll a die is first there are 6 events, okay, 1 to 6, all right, and there are 3 even number, okay, 2, 4, 6. So this is the probability. If you roll a die, it is you get an even number, okay. So probability is its definition is this, okay, it's a ratio of 2 number, okay, of different events. All right. So let's see some very simple example. I believe that you did it, okay, in Form 3 or in your DSC, right? A bag contains 1 red ball, 2 yellow balls, and 3 blue balls. If you randomly select a ball, what is the probability it is red? Okay. First, you count totally how many balls. There are 6. Red ball, there is 1. So probability is 1 over 6. Very easy. What is the probability that the ball drawn is a blue one? There are 3 blue balls. So it is 3 over 6. All right? Okay. So this is easy because it only includes a single event. How about this? If it involves two events, 2 coins are tossed, find the probability that both coins show the same result. First of all, we count how many possible events are there. That is, you count the size of the sample space. If H represent head, T represent tail, so the outcome are head, tail, head, or tail, tail. If both show same result, okay, so they are head, or tail, tail. So it is 1 over 2. Okay. B is at least 1 coin, so a head, at least is maybe 2, maybe the first one or the second one. So the result is 3 over 4. Okay. Understand, student? Very straightforward example, right? Okay, next. Now first, we learn some probability rules. So, okay. Now, I believe that some rules maybe you heard them before, right? Now for any event in the sample space, we learn it, the first rule in Form 3, right? The probability is result always lies between 0 or 1, okay? That is as a decimal number, which is less than 1, and also it is a 0 or above positive number. Okay, this is the first rule about the probability. Okay, probability. If it is 0, that means it is the event is impossible. Impossible. Can you find an odd number which is divisible by 2? It is impossible. Okay. 2, probability of PS is 1. S represents the sample space. The whole sample space probability equal to 1. Okay, equal to 1. This is the second rule. The third one is the complement of A equal to 1 minus PA. Again, do you remember the Venn diagram? Okay, if the circle inside represent A, then outside is represent not A, right? So the probability of A plus the probability of not A equal to 1. That is the whole sample space. So if we arrange this equation, PA bar is 1 minus PA. Okay. Now another rule also very useful is to connect the relationship between the union and the intercept. It is called the additive rule of two events. You may use a Venn diagram, very easy to understand why. Okay, for example, two events, there is some overlap. Okay, now I use 4 number to represent different region. 1, 2, 3, 4, right? Now, PAUB is 1 plus 2 plus 3. Okay, AUB is 1 plus 2 plus 3. Okay, this is the left-hand side of the equation. How about right-hand side? Okay, PA plus PB minus PA intercept B. PA from the diagram, 1 plus 2. Okay, now don't mix up with, don't think that PA is 1. Okay, if only 1 is called A only. Okay, not only PA is A only, only in A. But PA, you accept something also in other sets. So PA is 1 plus 2. And PB is 2 plus 3. Okay, 2 plus 3. Get it? Okay. And A intercept B is 2. Is 2. So to simplify it is 1 plus 2 plus 3. So we prove that AUB is PA plus PB minus PA intercept B. This is called the additive rule of probability. So students, please remember these 4 rules, okay, on doing or solving probability problem. Next. Then a simple example is a die is thrown, find the probability of getting a number greater than 2. Again, the sample space 1 to 6. Greater than 2, there are 4 numbers. So it is 4 over 6. Okay. Next one, greater than 2, greater than 6. It is impossible. No number greater than 6. So it is 0 over 6. Okay, less than 7, there are 6 number, 1 to 6, less than 7. So the probability is 1. Less than 3 or greater than 5, okay. Less than 3, 2 number, 1, 2, or greater than 5, 1 number, 6. So probability is 1 over 2. Last one, less than 4 and is an odd number. So 1 and 3. So answer is 2 over 6 or 1 over 3. Get it, student? Very simple. Okay. Now, on solving probability problem, sometimes you may find this technique, tree diagram is useful. Okay, useful. 3 fair coins are tossed. Find the probability of getting exactly 2 heads. Okay, so if you use a tree diagram, then the first coin outcome are head or tail. The second one also head tail. The third one also head tail. Then you trace the tree diagram, you can obtain their outcomes. Okay, outcome. Then after you get the sample space, you can easily solve the question. What is the probability the event getting exactly 2 heads. So you find there are 3 events. 3 events. So it is 3/8. Next one, at least 2 tail. At least 2 or above. So there are 1, 2, 3, 4. 4 events. So therefore, the value is 4/8. Okay, and it is 1/2. 1/2. All right, student. Another technique is to draw a table. Draw a table. This method is especially useful if the problem is a 2-dimension. So that is, there involve 2 events. You have to find out their union or their intercept. 2 dice are thrown. Find the probability of getting the same number on the 2 dice. So this is the outcome of the first one. That is the outcome of the second one. Okay. So you find their intercept. Okay, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, etc. So totally there are 6 times 6, 36 UN. You learned this in the last chapter, counting multiplication rule. Okay, 6 times 6. A, find the probability of getting the same number on the 2 dice. So if you trace the diagonal, okay, so there are 6 events. So answer is 6/36. Next one is find the probability of getting a total of 8. So from the table, you find there are 5 events: 2, 6, 3, 5, 4, 4, 5, 3, also 6, 2. So it is 5/36. Okay, quite easy. So up to now, you learn 3 graphical techniques may help you to solve a probability problem. First one is a Venn diagram. Okay, Venn diagram. Second one is the tree diagram. The third one is to draw a table. So, okay, draw a table. All right. Are you clear? Okay. And we may also use the technique you learn in counting to find the probability. A team of 5 is chosen at random from 6 boys and 4 girls. What is the probability that they are all boys? 3 of them are boys. Only 1 girl is chosen. So it's like there are 2 groups of person, right? And there are 6 boys here, 4 girls there. Okay, so in case 1, all are boys. So all the members comes from boys. So use NCR 6C5, all right, over 10C5. 6C5 over 10C5 is 1/42. 3 of them are boys, so 3 are boys and 2 are girls. So we use this expression. Okay, 6C3 represent the boys, 4C2 represent the girls, and the denominator is 10C5. 10C5, it means that if you regret the gender, okay, just randomly choose 5 person, right? So it is 10C5. So answer is 10/21. All right. So similarly for 4 boys and 1 girl. All right. Okay. So counting, use the counting technique to do it. Okay. Then student, I give you 1 minute or 2 minutes. Please read this example. Okay. Example of drawing objects from card. spade 即係葵扇啦嚇。Okay, A, 5 cards, all are spade. There are 13 cards. Okay, 13 cards. Which are spade, right? Randomly choose 5. Answer is 13C5. If you ignore the suit, 15 to C5 即係乜嘢花都唔緊要嘅嚇。15 to 52 C5. Next one, 5 cards of the same suit. Okay, 即係同花啦嚇。Okay, for a single say for spade, there are 13 C5 to do it, but among the suit, 4 you choose 1, so times 4 C1. So answer is this number, or it just is the answer of use A times 4. Okay, times 4. C, 3 A's and 2 king. Okay, A's, there are 4 cards. King, also 4. Okay, so it's a 4C3 times 4C2 over 52 C5. Okay, C5. A full house. What is full house? 中文叫俘虜嚇。3 cards with the same number or letter, 2 cards with the same other letter. Okay, so it is a bit complicated, right? And first, you solve this problem by using a particular case. If for 3 A's and 2 K, if we consider this particular pattern, right? Particular pattern, so it is the answer of this one, 3 A's and 2 K. But full house mathematically is 3x with 2y. Okay, 2y. So there are 13 ways to choose the first number. Agree? 13, there are 13 different numbers or letters, and 12 ways to choose the second. So we multiply this single unit by a factor. So this is the answer to obtain the full house. All right. Then this example, so you use the NCR approach to solve the problem. Okay. Example 11, maybe I left you to read it on your own, right? Read it on your own. But in this example, pay attention, there is a one word is called the mutually exclusive. 中文咧就叫做互斥事件。Okay. 互斥事件 mutual exclusive, that means the two events, they cannot occur together. Maybe for example, you choose a card, the card is a spade or a heart. Okay, a heart. Okay, so that you see that there's no card is a spade, also it is a heart. Okay, so to solve this question, we use the addition rule. SUH is PS plus PH minus PS intersect H, since it is mutually exclusive. The last term is impossible, so its value is 0. So space union heart equals to P space plus P heart. All right? Okay. But for the second one, select a card which is ace or a heart. In this case, there is one single card. There is an overlap. If you use a Venn diagram, is okay. This is ace. This is heart. Okay. There is one card. One card. This is which is overlap, and there are 3 other ace, and also 12 other heart. Okay, so to find out the probability, first you find the probability of ace. There are 3. There are 4. Probability of heart it is 13. Probability of the cards in common, there is 1. So this is the answer, 4 over 13. Right. Are you clear? Okay, then we use the additive rule to solve the problem. Okay, and example 12, I let you to be your own reading material. Okay, please read example 12. Okay, and use similar technique, the NCR approach to solve the problem. All right. Now then we go to a bit difficult section, is called the conditional probability. 中文咧就叫做條件概率。Sometimes we may wish to alter our estimate of probability of an event when we have additional knowledge that might affect its outcome. Okay, that is you use, maybe you heard it before. Given that, okay, given that you know something, what is the probability on doing a certain event? Okay, such as let us look at this example. There are 50 students in a class. Okay, this is a table to show the distribution, their gender, and also their stream. If you choose only one student, what is the probability the student is a boy art student? Boys art. So the 7 come from here. Okay. This number represent boy and art. All right. So probability is 7 over 50. 50 is the total number of students there. Okay. Are you clear? Okay. Now, but suppose that the student is known to have been drawn from the 24 boy student. It means that we are not choose a student from the whole class. We only choose the student from the boys group. So in that case, we only look at this row. So there are 24 boys there. Okay. So the probability, given that the student is a boy, he study arts, is 7 over 24. And this is the idea about conditional probability. Given that the student is a boy, what is the probability he choose his art? Okay, so we use this symbol to represent it. Okay, probability. This is probability. Okay, we put a stroke here. So given that the student is a boy, he study arts. Okay, you study art, is 7/24. Okay, this type of probability we call this conditional probability. 中文叫條件概率啦。All right, and if we use a symbol to show the abstract, okay, about the probability, what are the probability meaning is okay, this is A, this is not A, the complement, the opposite, okay, not in A. This is B, this is not B, right? And this represent the number in each different event. Okay, now let's see what is the relationship between the conditional probability and the other probability. Now, by reading the table, what is probability of B given A? Given A, that means we only concern the number in A. So the denominator is NA. Okay. Given A and the event belongs to B, so that we concern another event here is N A intercept B. That is this number. All right. Now, if we divide both by ns, the sample space size, we change the fraction to this form. Although we change the fraction, we do not change the value, right? Okay. Now, but what is the meaning of it? This is A intercept B. What is the meaning of it? This is a PA. So we connect the relationship between the conditional probability and also the other two probability. B given A is A intercept B over PA, provided that PA is not zero. Otherwise, this fraction is undefined. You can't divide a number which is zero. Similar thinking is what is A given B is PA and B over PB. Okay, A and B over PB. In probability, A and B is the same as Okay, same as B and A. Okay, so how to memorize this equation easily? Very simple. What is the probability of Px given Y? Remember this number, you put it here. All right. And next, you perform the intercept of these two events. Okay, right. And from these two equations, you obviously see PB given A is different from PA given B, since they are denominator. They are different. Okay, they have different denominator, so their values are also different. It's not mathematically, we call it is not symmetrical. Okay. All right. Let's see one example. 100 students go to a camp. After grouping, the number of boys and girls in each group are as follows. If A student is chosen from the group, the student in group 2, okay, group 2, there are 25 students, so it's 25 over 100. B, the student is a boy, okay, this row show you totally there are 60 boys, okay. C, the student is a boy in group 2. Boy in group 2 is this one, 18, okay, 18. Next one is that the student is a boy, given that it is in group 2. So given that it is a group 2, it is so symbolically is a B given A. Okay, B given A, because A A is the event that the student is in group 2. So B given A by using the equation is A and B over PA, right? And A and B copy from C. BA is a copy from A, so you did it. Okay, get it? Use the equation. And E is the student is in group 2. Given that the student is a boy, so in this case we reverse the two variable, become A given B is A and B over PB. So similarly, we copy from above, so it is a 3 over 10. This is the conditional probability. All right, are you clear? Okay. Okay, then all right. Now this example, maybe you read it on your own. Okay. It's quite similar. Okay, it's just a conditional probability problem. Example 15, right? The probability that a regular scheduled flight arrive on time is 0.92. The probability that it depart on time is 0.83. And the probability it arrive and depart on time is 0.78. Find the probability that a plane departs on time, given that it arrived on time, right? So this is the probability symbol, B given A. Okay, B given A is A and B over PA, right? So we just put the number, quite easy to solve it. Now we reverse, arrive on time, given that it departs on time. So it's A given B, all right? So it is A and B over PB, so 0.78 over 0.83. So it further verified that the two events, they are different. Okay, are you clear? Okay. Now maybe I'll give you 3 minutes. Please read example 16. Okay, example 16. Okay, student, understand the conditional sense of this problem. Okay. We already prepared some exercise on helping you to understand this conditional probability. Okay, and please remember to attend the tutorial no matter face to face, in person, or use the Zoom. All right. All right. Now next we go to the multiplication law of probability for independent event. Independent event 中文咧就叫獨立事件啦。For two events in a sample space, event B is said to be independent of A if the probability that event B occurs is not affected by whether event A has occurred or not. Put it simple, if there is a box, there are 2 red balls and 3 white balls, right? Now, if you take one ball from the box, okay, and then it asks you what is the probability that if you take the second ball from the box, okay, and which is a white ball, right? White ball. But it is given that if you the first ball you take from the box, you put it back before you take the second one. So in that case, no matter the color you get in the first event, it does not affect your result of the second event, right? In that sense, it is called independent. So if it is independent, put it simple is B given A, given that A occurs, what is the probability of B? If they are independent, it means whether A occurs or not, it doesn't affect the event of B. Okay, so they are equal. Okay, they are equal. So PB given A equals to PB. So okay, so on the other hand, PA given B is also equal to PA. So if B is independent of A, implies that A is also independent of B. So to define independent event, this is the definition. If PA given B equals to PA or PB given A equals to PB, so they are called independent. Another method is use the conditional probability definition. If A given this A given B is PA and B over PB, A given this is the definition of the conditional probability, right? So if we rearrange, multiply this term to it, become this one. But if they are independent, this become PA. So if two events, they are independent. So PA, A and B equals to PA times PB, right? Now, but student should be very careful. Independent event, 獨立事件, is only a special case in probability. Okay, it's a special case in probability. It is not a general case. Okay, in general, should be this one. Should be A intercept B is PA given B times PB. Okay, times PB. Remember this. Okay, once again, independent event is only a special case in probability. It's something like, I think you all learned a triangle before, right? A right angle triangle is only a special case in triangle. Okay, not all the triangle are right angle. Okay, triangle definition is only three sides connected. Okay, so be careful on the independent event. Otherwise, you will make mistake on solving the problem. Okay. Now let's see one example to to show how do we prove that two events they are independent or not. When you toss a coin 3 times, consider the event. A is the event that the first toss is head. Okay, B is the event that the last toss is tail. C is the event that the total number of head is exactly 1. Compute PA, PB, and PEC. Now, PA is the first toss is head, so they are 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, the starting head, 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 head. Okay, so there are 4 events. PB is the last toss is tail, 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 tail. It's also 4 over 8. Finally, is PC is the event that the total number of head is exactly 1. Okay. So there are only 1, 1, 1. So it is 3. Okay. Now, and please find PA given PB given A, and so it is the two events are independent or not. Now, we use the formula. PB given A is A and B over PA. Okay, we find PA already here. Okay, but what is A and B? Okay, A and B is the event is the first toss is head and the last one is tail. The first one is head, the last one is tail. First one is head, last one is tail. So it's 2 over 8. So it's 1 over 4 over 1 over 2. We said the two events, they are independent because you find this answer equals to PB. Next one. A and C are independent or not, right? Now we know PC already. This is 3 over 8. Okay. Now, so PC given A is, we use the formula A and C over PA. Okay, it is what is A and C? Okay, A and C is A is the first total is head. Second one, the total of a head is exactly 1. So the pattern is HTT. HTT. Okay, so there are 8 events, only one event belongs to A intersect C, so it's 1 over 8 over 1 over 2. So you find it is a 1 over 4. A 1 over 4 is different from 1 over 8. So we prove that they are not independent or they are dependent. OK， 即係兩件事咧係有影響嘅，互相之間得唔得？非獨立事件嚇。OK，so this is to show you how to prove the independent or dependent event. Are you clear? Okay. Next one. A similar example is I give you 3 number. Prove that they are independent or not. Okay. If A, B are independent, A given B equals to PA. But obviously, from the question, PA given B is 1 over 2. PA is 1 over 4. So not independent. Very easy. Now, are they mutually exclusive? Now, mutually exclusive is the two events, they are disjoint. okay, if they are disjoint. So if they are disjoint, what is the probability that given B occurs, A occurs, should be 0, okay, because they are disjoint, okay, but A given B is 1/2, so they are not mutually not mutually exclusive. Another method to show mutually exclusive event is to use the result of C. Now, A intercept B by definition of the conditional probability is PA times PB given A, right? Do you understand? Because PB given A is PA and B over PA. We just multiply this term to this one, then you get this one. So A and B is PA times PB given A. So use the information, you find that it's 1/6. Okay, so A and B is 1/6. And also because 1/6 not equal to 0. So if it's not 0, then it implies that they are not mutually exclusive. Okay, clear? Okay. Finally, is to find PB. We use the equation again. A and B is PB times PA given B. So simple substitution, you find PB is 1/3. Okay. Now, multiplication law of dependent event. Two events are said to be dependent if the occurrence of one affects the occurrence of the other. If two events are dependent, where A occurs before B event, so we said it's B given A. So PA by definition is PA and B over PA. Okay. This rule is called the general multiplication rule. And this general multiplication rule can be represented by using a tree diagram. Now listen to it very carefully. Now, if there are two events in the sample space, the probability that both of them occur can be calculated by this one. Now, first, this is PA. Next is P naught A. So this path is P naught A. Okay. Now be careful this. This one, no, is not PB. And also, it's not PB A intercept B. Be careful this one. Okay. Not this one. Not this one. The correct one is this one. PB given A. First, this is a given condition. PB given A. So similarly, this one is PB not given A. This one is PB given not A. This one is P given not A. Okay, be careful. So to find the intercept, we multiply this one and this one, you get this one. All right. So what is the result of the second one? If you multiply this number with this number, the result is P A intercept not B. Be careful. Okay. So on solving a conditional probability problem, tree diagram is a very useful tool. Okay. Remember to use it, and remember to define each path correctly. All right. Okay. So example 19. there are 2 red balls and 1 green ball in the bag. Find the probability of getting a red ball in the first one and the green ball in the second draw if the 2 balls are drawn at random 1 by 1. So very simple. If the first ball is red or green, the second one red or green, red or green. But in A is with replacement. In this sense, the probability does not change when you draw the second one. So it's 2 over 3, 2 over 3. Okay, no change. Okay, if it is 1 over 3 for green, the second one is also 1 over 3 for green. So that if with replacement, put it back, then of getting a red ball first and the second ball in the second, so you trace the diagram. First one is red, second one is green. So it's 2 over 9. Okay. But if you, without replacement, you do not put the ball back. So the first one is red, is 2 over 3. But the second one is red, is 1 over 2 because there are only 2 balls. One of them is red, so it's 1 over 2. If it is 1 over 2, it is 1 minus 1 over 2. Use the complementary rule, okay? So it's 1 over 2. Next one is, if the first one is green, okay? If you do not put the green back, then the second one must be a red ball. Okay. So the first one is red, the second one is green, is 2 over 3 times 1 over 2. You trace this path, right? So understand on this illustration how to use the tree diagram. In the tutorial, you will some question will give to you on practicing the tree diagram. Okay. Example 12 is similar, but in that case is there are 12 eggs, which 3 are rotten, if 2 eggs are selected at random without replacement. Okay, so you draw a diagram first. The first one is a good, okay, bad. The second one, good, bad, right? And next is both are bad. Okay, so you trace the diagram from the first one. The first one is rotten. The second one is also. So you trace this path. Okay, and you find this answer, 105.22. Okay. B is exactly 1. Exactly 1 means the first one is bad, the second one is good, or the first one is good, the second one is bad. So you trace the diagram, easy to do it. Now again, probability, you may use another approach to do it, is by using the combination. You can also reach the same answer. In this sense, problem, there are 2 groups of eggs. Okay. How many of them are 3? Is it 3? 3 3. Okay. 1 is rotten, so you give 1. Then this is also, you choose 1. Okay, and you may use the NCR to do it. Okay. Next one. Finally is at least 1. At least once you saw this, there are 2 approaches to do it. Okay. So is calculate exactly 1. At least 1 can be both. Or you may use a complementary way. First of all, calculate both are good and use 1 minus the answer. You can also get this number, 5 over 11. Okay. And finally, okay, up to the end of this lecture, and next is the generalized the conditional probability that is called the Bayes theorem， 咁叫貝氏定律啦，非常之出名嘅定律。OK， 杯氏定律 is extend the conditional probability. That is very easy. If for the first one, there are different events on doing the first one, and under different condition, there are different event, different probability on the second event. Okay, so to calculate the event that pay attention on it is, we want to find given A first, the probability of a certain event. What is the relationship between when these two variable, two letters are reversed? So here is, you see that the two letters, they are reversed. Okay, they are position. Okay, so to find, that is pretty simple. If you know A given B, A given E, how do you obtain E given A? That is the base theorem I want to say. Okay, so using this is you can find it. Okay, you can find it. Very simple. That is, first you calculate the total probability, okay, of this event. Okay, then you put which one you want to find, and you put the particular one in the denominator and take the ratio. This is the base theorem. Okay. Okay, understand? So this page is to illustrate the diagram. Okay, and what is the logic and how do we obtain the answer? And student, please read this page. Okay, if you have problem, ask your lecturer. Okay, not difficult. Actually, it's only the conditional probability, but extends. Okay, extent of it. All right. So let's see. The last example is a visitor to a certain country are required to undergo a blood test for a certain kind of disease. If a visitor has the disease, the test has a probability 0.9 showing a positive result. But even if the visitor does not have the disease, the test still has the probability of 0.05 of showing the positive result. That is wrong diagnosis. So the tree diagram is, has the disease, you can find it, you check it. But without the disease, but the instrument also show that the person is sick. Okay, so this is the tree diagram. What is the probability that a visitor selected at random will give positive result? So we trace the diagram. This is positive result. This is positive result. So we trace it by this path combined with that one, right? So path 1 plus path 2. So the answer is 0.118. 118. Get it? But suppose the visitor blood test give a positive result. What is the probability he has the disease? That is correct diagnosis. So given that, okay, given that positive result, then the patient has the disease. Now, if you use a conditional probability, simple version, right? So it is a disease and with the positive result over positive result. Okay, so this number, positive result, 0.118 is found from A. Okay, from A. How about this one? Is with the disease and positive result. Trace the diagram with the disease and positive result, 0.08 times 0.9. All right, so very simple. You get that this is a 36 over 59. Okay, now this number is also sometimes used in some medical to check that whether what is the reliability of your instrument on checking the disease. Okay, right. All right, now this is all about chapter 3. Okay, and student, please, if you don't understand the concept, I suggest you to watch the tip again. Okay, watch the teaching again, and then ask question in the tutorial. Your lecturer will prepare some question for you to on practicing this chapter. Okay, I really hope that all of you enjoy studying statistics. Okay, and this is using a Blender mode. I hope that everything later will go smooth, so we may use face-to-face on teaching, although it's very difficult. Okay. Okay, see you in the next lesson. Bye-bye.